Hello friends, welcome to my channel. In this video we will cover SSC JE 2020 solution 11th December 2020 shift 1. We will discuss technical part only. We will discuss. This is part 5. Question number 155 onwards we will discuss. Question is the process by which air inside a centrifugal pump is removed and filled with liquid to pump is called as. So we are removing air inside centrifugal pump and filled with liquid. This is priming. In our household Tulu pump also we used to do that. It may be self priming or you have to do priming by manual methods. You have to fill water, then after priming only the liquid will lift or water will lift. So answer is priming. Question is figure shows the PV diagram for a fixed mass of an ideal gas undergoing cyclic process ABCA. AB represents isothermal process. Which of the graphs shown in the figure represents PT diagram of the cyclic process? I think some printing mistake is there in options, because AB it's a isothermal process. Isothermal process means in PT diagram it should come like this. It should come like this, vertical, AB process. Then near BC is a constant pressure process, means it should come like horizontal. In none of the option, AB is vertical, BC is horizontal. In A, BC is horizontal, then BC, only option A, you are having BC horizontal, but AB it's not vertical. Maybe printing mistake is there, so no problem, you will get grace mark, or they will omit this question while calculation. Next question 157. The water is flowing through a pipe having area 0.05 meter square at section 1 and section 2 area is 0.01 meter square. Here also printing mistake is there. Then the rate of flow through the pipe is 50 liters per second or 50. If you want to convert in meter cube per second, you have to divide 1000 per second in section 1. The velocity at sections 1 and 2 is how much? And we know if you follow continuity equation, Q equal to A1 V1 equal to A2 V2. So same quantity of fluid flowing in section 1, same quantity you will get in section 2 also. So Q equal to for section 1 A1 V1 it's equal to A2 V2. Then you have to calculate V2 and V1. No problem. Q equal to A1 V1, and from here V1 equal to Q is how much? It's 50 liter, 50 by 1000 divided by A1 is how much? A1 is 0.05 meter. You can write 5 divided by 100. 1 meter square per second. 1 meter per second. Its velocity so meter per second. So from option B not possible, then your D also not possible. Then again Q equal to A2 V2. V2 equal to 50 by 1000 divided by A2 is 0.01 or 1 by 100. 5 meter per second. So again from option here it's 0.5, so A also not possible. Only option left C. V1 is equal to 1 meter per second and V2 equal to 5 meter per second. So C is your correct answer. Only you have to put continuity equation. Question 158. The coefficient of velocity Cv for an orifice is 0.98. Head loss at the orifice for discharge under a head of 200 cm is how much? So HL value you have to calculate. Head loss value you have to calculate. Orifice. Formula is Cv equal to root over of 1 minus HL divided by your head whole root over. So Cv value given 0.98, then head value given 200 centimeter. All options are in centimeter, so no need to convert. 0.98 it's equal to, just square it, no problem. 1 minus HL you have to calculate 200, then 98 by 100, 98 by 100, 200 minus HL divided by 200. Here you will get 50. Then you have to do approximation. You put 100 here, 2, then 98 into 2, 196 minus 196, you will get 4 centimeter. Actual value it should greater than 4 centimeter. So greater than 4 centimeter, C is the only option. Approximation you have to do. Otherwise you can calculate also, but it will take some time. So it's better you go for approximation method. Question 159. The rate of change of momentum is equal to the applied force and it takes place in the direction of force is a statement. This is second law of Newton's second law. Newton's second law, Pascal equation, continuity equation, impulse momentum equation. Yes, C is a correct answer. Impulse momentum equation. The rate of change of momentum is equal to the applied force. Newton's second law, F is proportional to m dv by dt. F equal to m into v2 minus and by dt, or f dt impulse equal to mv2 minus mv. This is impulse change in momentum. Newton's second law of motion. So C is your correct answer. Then next question. Relation between shear stress and velocity gradient for Newtonian fluid. Newton's law of viscosity. Newtonian fluid. The relation between shear stress and velocity gradient of Newtonian fluids. So graph, if you follow, shear stress dv by dy, or you can write d theta by dt also. D theta by dt is a rate of change of your angular momentum. D theta by dt is your shear strain rate or your rate of change of angular deformation, and dv by dy is your velocity gradient. So relation between shear stress and velocity gradient for Newtonian fluid. Tau is proportional to dt, or tau is proportional to rate of change of angular deformation. Sorry, this one dv by dy, velocity gradient. or tau equal to mu dV by dy. Mu is your coefficient of viscosity, or your dynamic viscosity, or your absolute viscosity. For Newtonian fluid, it's linear. It will come like this. You will get a straight line, linear relation. For Newtonian fluid, you will get mu equal to constant, or mu equal to tan theta. Theta you will get here. This is theta, or mu equal to tau divided by dV by dy. And in Newtonian fluid, we know coefficient of viscosity remain constant. The next question, Rankine cycle efficiency is dash than as Carnot cycle efficiency if both work under the same operating temperature. Rankine cycle comparison with your Carnot cycle. So Rankine cycle TS diagram we will draw. One to 2, then 2 to 3, 3 to 4, 4 to 1. Then if you compare with Carnot cycle, TS plot, you will get same temperature limits. So T1 you will get here. One to 2, 2 to 3, 3 to 4, and 4 to 1. Here you will get Q supplied or heat addition in constant temperature process. But here in Rankine cycle, heat supplied, it's not a constant temperature process, it's constant pressure process. So if you want to calculate, you have to take mean temperature of heat addition. If you take mean temperature of 2 and 3, you will get like this. T mean, this is T mean. So here point will come here. We are not adding heat at maximum temperatures in Rankine cycle. But in case of Carnot cycle, we are adding heat in maximum temperature. Because of that only, Rankine cycle efficiency is less than Carnot cycle efficiency if both work under the same operating temperature. So A is your correct answer. Because in Rankine cycle, we are not adding heat at T max or T3. Next question, the flow field is expressed as U equal to A cos alpha and V equal to A sin alpha for a constant A and alpha. The equation of streamline passing through origin in this flow field is calculated by. So equation of streamline you have to calculate. Data given, U equal to A cos alpha, V equal to A sin alpha. Equation of streamline dx by u equal to dy by v, it's equal to dz by w. but W value not given, so we have to consider it as 2D flow. dx by u equal to dy by v, and if you integrate you will get x by u equal to y by v plus c. It's passing through origin, so c equal to 0. x by u value how much? A cos alpha. Y by v is A sin alpha plus 0. So y equal to x sin alpha by this is your answer. Y equal to x tan alpha. D is your correct answer. Only thing you have to remember here, passing through origin, c equal to 0. Then this streamline equation, this one very important. Next question, a turbine rotates at 600 rpm if moment of momentum of working fluid. Moment of momentum means a torque of working fluid is reduced by 15.915 kilonewton meter. Then power developed in megawatt is how much? So you have to calculate power developed. N is equal to how much? RPM, 600 RPM, then 15.9. If you want to calculate, you can calculate. Finally, approximate value you will get 1 megawatt. B is your correct answer. Here only you have to apply this formula. P equal to 2 pi nt by 60. It's in watt. It's already in kilonewton meter. So you have to divide it only 10 to the power 3 for megawatt. Then approximation you have to do here. 2 into pi you take 6. 15.9 into 6, around 100 you will get 100 by 100, 1 megawatt. Approximate value B is your correct answer. Next question, steam jet draught is used in, it should be locomotive boiler. B is your correct answer. If X represents the dryness fraction of steam, the specific volume of wet steam is given by how much? So, specific volume of wet steam. TS diagram we will draw. One point, then this one 3 point, 2 point. You can take anywhere in between 1 and 3. So 1 point you will get. This is your liquid region. So 1 point you will get wet steam or saturated liquid steam you will get, and between 1 and 3 you will get, this is saturated liquid line. Saturated liquid, here saturated vapor. you have to calculate one wet stream. Wet stream means between 1 and 3 anywhere you can get. Let it be 0.2. Wet stream, 1 is your saturated liquid, then or saturated fluid. That value of V1 is saturated fluid, so Vf. V3 is saturated vapor, so V3 equal to Vg. You have to calculate V2 value. V2 is V2 equal to Vf V1 plus x into Vfg, or you can write Vf x into Vfg is a Vg minus Vf. So if you compare specific volume of fluid and specific volume of vapor, specific volume of vapor is very greater than your Vf. So Vf equal to 0. Finally, it's approximately, it's very less value, so you can take it as 0. This is your answer. Specific volume of wet stream, or V2 value, you will get x into Vg. A is your correct answer. If you want to guess also, x square not possible. This one also x square Vf. This one also not possible. Either x into Vg or x into Vf. And Vf value is very less. Specific volume of fluid is very less than specific volume of vapor. So A is your correct answer. No need to calculate also. Question number 166. In an ice engine, the type of lubrication system used for bearing is mainly bearing lubrication. Question from options we will check: boundary lubrication, mixed film lubrication, hydrodynamic lubrication. Yes, C is your correct answer. Next question: if a thermometer is used to measure temperature in a moving stream in a nozzle, it measures dash temperature. Thermometer, moving stream in a nozzle. It should measure stagnation temperature. B is your correct answer. Ratio of power available at the rotor shaft to the power supplied by water to the runner is how much? So we know, first you will get water power, then you will get runner power, then you will get shaft power. Hydraulic efficiency, this is your runner power by water power, or power developed by runner to power supplied to the turbine entrance. Supplied to turbine entrance. Then you will get your mechanical efficiency. Mechanical efficiency is your shaft power by runner power. Power available at turbine shaft power developed by runner. Then overall efficiency. Mechanical efficiency into hydraulic efficiency. Mechanical efficiency is your shaft power by runner power into hydraulic efficiency runner power by water power. So finally you will get shaft power by water power. Shaft power is power available at turbine outlet divided by your water power, net power supplied to the turbine entrance. So power available at rotor shaft is your shaft power supplied by water to the runner. Water power. So shaft power by water power. Your overall efficiency. So D is a correct